In today's episode, I'm going to look at a hybrid amplifier. A hybrid amp uses the best of transistor and vacuum tube technology. Basically, we call it a tube buffer a lot of times today. They use a couple tubes to add some warmth to the sound. This one uses MOSFET outputs. Was a very expensive amplifier when it was new. I've got one. I paid over $2,000 for mine back in the early 80s, and that was a lot of money for a 60-watt amplifier. This is a Luxman. Let's check it out. Today I have a Luxman LV103 in for service. No, this is not my Luxman. This is one that was brought in for service. I don't know what's wrong with it, so first things first, I'm going to take the top off it, and then we're going to power it up and see what it does. One thing that was interesting to note for these Luxmans that were sold in Canada is they're not CSA or Underwriters Laboratory approved. There's no UL sticker, there's no CSA sticker. They all have this Ontario Hydroelectrical approval by Special Inspection Series A on all these products that were imported into Canada. Mine has the same sticker. Okay, here's the inside of this one. Looks like this one's never been touched. First thing I'll do is check the fuses and see if the fuses are popped. Nope, that one's good. As is that one. Okay, second thing I'm going to check is for continuity or some type of continuity on the power cord. Put the meter in ohms mode. Right now everything's turned off. All the switches are off. So there should be, I think everything's off. I guess it's the preheating probably just keeps that's probably the transformer for the standby. Because when I turn on the main power switch it drops to 3 ohms, but there's a second transformer that is used, and there's a switch for preheating, but it doesn't make any difference, so that must just switch the secondary off of it. That's the filament transformer for the tubes that we're seeing. It's always got power on it, but we know that the transformer is not open. The thermal fuse inside here is not open. That's a good sign. Next thing we'll do is we'll check for any shorts on the outputs, because shorted outputs would be a bad thing, especially on a unit like this, because these transistors are pretty much obsolete. Although I've never seen blown outputs on one of these units. These amplifiers were usually fairly well protected. They are MOSFET outputs, and there is no shorts, which is good. Okay, so the outputs are not blown. Next we'll apply power and just see whether the unit will power up. I'm going to plug it into the dim bulb tester and have everything turned off, of course. First thing I'll do is I'll power up the preheating and see if it lights up. And the preheating light comes on when I turn it on here. We're going to look for the tubes themselves warming up. It's going to be tough to see with all the light in here, but I'll let them warm up for a few minutes and see whether I can see any light coming off the tube filaments. In this case, night shot is our friend. I can see them glowing. So can you with the night shot turned on the camera. If I turn off night shot, you probably won't see much. There we go. So with night shot off, of course, we don't see anything. The infrared off these tubes is pretty low. They're not that bright when it's in standby mode. When I turn it into full power mode, then we will see the light. They'll start to light up brighter. So now the unit is drawing more power, and we'll obviously see the filaments getting hotter. I just heard the relay click. So is this amplifier going to work? Dim bulb is not drawing excessive current, which is good. That's the only light that's on in here right now is the dim bulb. As I start to turn my lights back on. See, I could probably film with just that amount of light, with just the compact fluorescence, but I'll put the rest of the house lights on as well. Well, this clicked. That's good. It's not going into protection. So let's hook up some speakers. The thing we should note is that the LEDs here, there's 4 LEDs on the board. They're illuminating. That's normal. That means that everything is working as it should. Let's switch it to the CD input. Make sure the volume is turned down to minimum. We'll turn on the speakers and see if we get sound. Ah, we have a bad volume control. Listen. Left channel is distorted. Oh, it's the switch. It's the input switch. We have a bad switch. That's what the problem with this one is. It's a bad input switch. It's going to need probably filter capacitors too. Yeah, it's a switch. This is the most common problem on these amplifiers. This has happened to mine more than once. These input switches here. These ones you see here, these are actually the switches for the tape record output. The other ones are below. But the input switches are the biggest headache on these units. I'm hearing a little bit of hum as well. So we probably got filter caps that are going bad on here. In the preamp stage more than likely. But the switches are bad. They have a little bit of AC hum. Actually, the AC hum is because I'm running through the dim bulb. My voltage is low. Speaker switch is also bad. Okay, so we know what we're up against. We got bad switches, and there's going to be some caps that are also gone bad on here that need to be replaced. So let's start on it. Oh, another reason why maybe it was humming a bit was because I am running through the dim bulb after all. Let's just get rid of that. Let it kick in. Give it full power. Ah, hum's gone. See, that was just the dim bulb. That's better. So, see, no hum. When I'm running on a low voltage, listen. You'll probably hear the hum come in there. See, it's humming because of the low voltage. Turn the dim bulb off. It sounds great. We got bad tone control with the tone in. That's going to be in the tone board. When it's in bypass, sounds fine. When I put tone on, it's bad controls. Let's clean those controls before I blow something else up. We can remove the bottom hatch because this amplifier was designed to be serviced. Unlike some brands, most brands now, but this one here was designed so you could actually remove the bottom cover. First things first, let's get the bass and treble controls cleaned up. So this one's the treble control. It's easy to get to. The bass control is a little more challenging to get to. I may have to pull the board out to get to it, but we'll see if I can get in here with some cleaner. That one should be clean. Let's see if I can get some neutral down into the other one. I gotta get my head in there so I can see what I'm doing. This control is cleaning up. It's getting nice and easy to turn as well. Okay, let's just see if that one is noisy still. The nice thing about these amplifiers is they're overprotected. So they will go into protection mode to protect the output transistors long before a lot of other amps will, which some people find is annoying. On these amplifiers, if you turn the volume a little bit too loud, rather than clipping and taking out your speakers, no, they just shut off. That's one thing I've always liked about this is I never have had to worry about popping speakers with my LV103. Because if I give it a little bit too much volume, it would cut out. In my case, it was cutting out all the time because This amplifier is rated at 8 ohms minimum, and I was running 6 ohm Altec Lansing, so it didn't take much to make it kick out for me. So tone control in. That's pretty good. A lot better than it was. Treble control's quiet. Yeah, it's a lot better than it was. A little pop in there. I think that'll probably work its way out if I just turn the control back and forth a few more times to clean it. Excellent. There we go. That's behaving a little better. At least it's not putting the amplifier into protection. A little bit of noise still at the extreme end of the control. Turn off the tone control while I do that, just to avoid unnecessarily giving my speakers a heart attack. Okay, there we go. That's better. That's much better. Excellent. Switch is good too. I cleaned that while I was at it. Now I gotta do these switches. These ones here need to get done as well. These switches are almost a sealed type switch. I found the best way to clean these is to actually drill a little tiny hole into the back using something small like just a little screwdriver, so that I can actually get some cleaner in. I might be able to do it through the edges here too, but I like to be able to soak these switches with, saturate them with cleaner, just to get them to clean up properly. So what I've done on my own is I actually use a very small screwdriver just to pop the tiniest little hole in the back here, so that I could get the nozzle in there and actually give it a good shot of cleaner, just like that. Right, just a small hole. It's not going to affect anything because we're not getting into the actual, we're not going to actually touch the switch itself. And this little tiny screwdriver is so sharp that it'll just put the smallest hole there so that I can put the nozzle up against it and flood the switch with cleaner. This way I can make sure that I get a liberal amount of cleaner into the switch, and you'll see it go right into the switch. I'm also not wasting as much cleaner because I'm not spraying it all down trying to get it into the switch. I'm not soaking everything else with cleaner. Alright, I've now cleaned the switches. No more noise. And this typically lasts quite a while. This is what I ended up doing on my own because I got tired of trying to spray the switches in from the back here or in from the front. Could never get them to clean. So this is what I ended up doing on my own years ago to clean the switches. And they've stayed relatively clean. I don't use my LV103 anymore because I ended up getting that SUV9, which has got more power and it's more friendly to the 6 ohm speakers. It doesn't go into protection. But I used my 103 for many, many, many years. I used that thing for probably 40 years. It was just a couple of years ago when I got the SUV9 given to me that I decided to put my 103 into retirement. But it was one of the best sounding amplifiers that I had. And I recapped mine. We're going to recap this one. There's not that many caps to change on it. But we're going to do that on this one as well, because this is a customer's unit and he wants it to sound the best that it can. But these amplifiers really do. Oh, even the volume control is clean. I didn't even have to clean it. How's the balance? Balance control is good too. So let's start changing some caps on the main board. These units do have some circuit glue that really needs to be scraped away, because it does, you can see where it started to deteriorate and go a bit conductive on these jumpers. So we really do need to kind of scrape away the circuit glue that's around the bottom of these caps, just where it touches other components. It's really the only place that we have to really worry about it. In around these jumpers, for example. Just scrape that out. Good old toothpick will take care of that. The caps that generally will go bad on these are some of the small ones. The red ones I'm not going to touch. These ones here, these Elna, these are audio grade, but they're bipolar caps, and they typically haven't failed on mine. The ones that typically have failed are the ones over on the preamp board over here. And what it did is it caused distortion on the Phono preamp. This amplifier sounds pretty good the way it is. You know, like I don't hear any sound when I'm listening to it here. I don't hear anything that directs me to bad caps on it. And when I redid mine, I noticed no change in the sound whatsoever between the original and the replacement caps. So we're going to check them out and check any of these ones for high ESR and change as required. Usually you see these little caps here. Most of this amplifier, these are in the power supply, with the exception of these red ones here. Most of this amplifier is mostly directly coupled anyway. So there's not a lot of capacitors on it. There's only a handful of caps in each channel. And there's a few over here as well on the preamp board. But first things first, we're going to scrape off that circuit glue, because that circuit glue here, as you can see, it's already started to cause some issues here around these jumpers. So we want to scrape this stuff off. Just get it away from the electrical contacts. It's fine to leave it on the caps themselves. It was put there to hold them down when it was being shipped. Now this amp, from what I understand, the guy that I got it from, it came out of a restaurant, and it had been, I guess it had been there, or a bar, whatever, I think it was a restaurant. He said it came out of, but it had been there for years and it hadn't been used for years, and it was just sitting around collecting dust. So he collected it, and of course when he went to try it, it didn't work. Well, yeah, the bad controls were part of the problem. So we're going to give this a once over and try to get the thing working and in good shape, so it should last for a while. But to say, mine has had a lot of use over the years. Like I used to leave mine turned on 24 hours a day, because half the time stuff in my computer room, I don't turn it off, I just leave it on. I try to shut things off now just because I've tried to conserve power, but back when power was cheap, I used to leave stuff just running. I always believed that it was better to leave equipment turned on than turn it on and off all the time, because I was brought up under the assumption that the most stressful time for electronics was the inrush of current when it was turned on. So I learned that from when I was working in the broadcast field for a couple of years there. There was signs up: do not turn off the cameras, turn them to standby, but don't turn them off. Do not turn off the VTR. And the only time the equipment was turned off was the mobile and our production truck, when we were actually traveling to a location to film. And as soon as we got there, we either plugged into house power or fired up the generator and fired up equipment again. But the stuff in the studio was never turned off, and the engineers had big signs up: do not turn off. Fastest way to pop transistors, diodes, and integrated circuits is to turn things on and off. That was the mentality that I was brought up on when I worked for, as to say, a stint in broadcast there for a bit, right out of college, out of BCIT, which is I took broadcast. Is what I was. That was my original first choice of work, was broadcast. Engineering was not on the radar at the time. I'd done electronic stuff more as a hobby when I was younger. When I was in high school, I did a lot of tinkering around with electronics, but it was never really my first choice. My first choice was television production and working at a TV station. Unfortunately, that did not pan out. I locked horns with the engineer a couple times, and the engineer did not like the way that I could solve problems out in the field. And, well, he just had his final say, and his final retirement, going away, FU, was getting me fired. Boiled down to, he went to management and told management that if I was hired full-time, that he would be putting in his notice. Did he feel threatened? Maybe. But my ultimate crime at the local cable station for getting fired was when a Panasonic, I think it was an NV 9800 maybe, or 9850, the same VCR that you saw on the opening to this video, the very first shot of the VTR unlacing, that was what we had in the control room. I removed a tape that got eaten by one of those when it was on air. It ate a tape on air, and it was the only machine I had to go to air with because the backup machine was in the shop. So my direct supervisor asked me if I could try removing the tape and cleaning the machine and see if it worked, which I did. It was a tape problem. Someone had spilt something on the tape and it got stuck inside the machine. Something sticky, namely sugar from coffee, from the boss that used to walk around with his coffee cup. But he seemed to be the only one who could get away with walking into the control room, eating and drinking. That was a forbidden thing, but he used to do it. Anyway, when the fit hit the shan, my boss threw me under the bus and didn't stick out his neck and say that he told me to remove the tape, and I got canned for it. And then the engineer basically at the time, I can say that the guy is dead now. The engineer, he died a number of years ago, but he quit the company 2 weeks after I was let go. He put in his notice and he quit, and he went and opened a TV repair shop in Winnipeg. He was from Winnipeg, and he went back home and opened a repair shop and finished his working days. And the guy was probably one of the smartest engineers that I knew. He was really good, right? He was, and I think that's how I used to annoy him, because when I wasn't doing anything, when I'd get to work early, right? I was doing master control. I would get to work early, and I would go and I'd watch him and talk to him about what was going on, what he was doing on equipment. And I think I annoyed him because I asked him too many questions. And then he used to get to the point where, because I'd done an intern there, and I'd done volunteer work prior to that when I was going to school. I did volunteer work there. And I think I annoyed him because I had too many questions, and he didn't appreciate. He didn't like sharing. He didn't like to share any of his trade secrets. If I asked him what was wrong, his reply was, "It's broken." He would never go into detail. The other engineer that was there, he was very good. The younger guy, he was really good. He would show me how to test stuff. He showed me how to do an alignment on a VCR it was 3/4 inch machines, and 1 inch. He would hook up the scope and show me what he was doing and how to set the waveform and stuff. He was great. He taught me a lot, even though I wasn't, because he knew I had never applied to go there as an engineer. I was trying to get into the production side of things. I wanted to work on TV production work, camera and directing and that type of stuff. That was my interest. I really wasn't interested in repairing the stuff at that time, but I wanted to know how it worked. So he would show me the technical side of things and how things worked and how the cameras worked and how the colors were mixed together and how to do registration, right down to like tweaking the actual individual registration instead of just the basic stuff. He would show me how to get in where you have to adjust the yoke on the pickup tubes, for example, and the magnetic rings on the pickup tubes. He would get into that type of detail, whereas Leo, no, the chief engineer, no, he would just it's broken. He wouldn't give me any info. Anyway, but we were on the topic from shutting things off. I used to leave my equipment running all the time just because of the notes that were around the TV station saying, "Don't shut the equipment off. It causes stuff to break down." So I used to follow that rule at home and leave everything running. But I don't now because of the high cost of power, electricity. You know, it's gone up many times over the years, and my hydro bill is high enough as it is. And a lot of you out there, I probably pay more for my hydro bill than some people pay for rent. No, maybe not quite that bad, but it's pretty bad. With electric heat pump for heat, and electric hot water tank for hot water, and 2 electric cars, and all the other crap that I use around here. Yeah, my bill is pretty high. I mean, when I had that current meter on, just the lights when I'm working here in the shop, just the lights was what, almost 6 amps at 120 volts just for the lights in the workshop here. And I don't even have them all turned on. There's some more around these other capacitors down over here. You'll see down here there's some more. So I want to make sure I scrape this stuff off where it's around conductors, just so that there's no chance of leakage, because it does become a little bit conductive when it breaks down. And this stuff is, of course, at this point in time, this stuff is all fully decomposed. So we just want to scrape away the circuit glue so that it's not touching any exposed conductors. So I just pulled out a 16 volt 47 microfarad cap from the board. This is one of the caps in the one of the channels. I think it's the left channel. So it's 16 volt 47 microfarad, 1.6 ohms would be considered to be good for a new capacitor. Let's just see what this one measures up ESR wise. 1.2. So it's better than what a new cap would be rated. Let's check the capacitance of this cap. I bet you they're all fine, because I found every one of them in mine was good. I changed it anyway, but I didn't need to. Oops. 48.5. This one's fine. I'm not going to make any noticeable change to the sound of this amplifier by changing this cap. I could change it because I've already pulled it. I'll grab a new 16 volt 47 microfarad. We'll measure it, but I'm not at any advantage to change that unless I want to just start adding parts so I can add to the price of the bill, which is what a lot of shops will do. A lot of shops will say, oh, you got to change out all the caps, because every cap they change, ka-ching, 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 and the price keeps going up. So let me find a 47 at 16. Here's a new one. Okay, it measures the same, 48.6. How's the ESR on this one? Okay, ESR is a little lower. Much lower. But then again, it's a high temperature cap. This is a low ESR, and it's a 105 degree. This original one was probably an 85. Yeah, 85 degree. So ESR on an 85 is going to be a little bit higher. But the fact that the ESR on this one here is still below what would be rated for a new cap, should I change it? I think I will, just because I've removed it. But I don't need to change it. There's no real reason that it needs to be changed other than the fact that it's old. So I'm going to change it for that reason, because there's not a lot of them. If there was 100 caps in there, I would be not changing them all. But since there's only a few, I've got the old one out for what a capacitor costs. I'm going to go ahead and change it. But it's not going to change the sound. It's not going to do anything for the sound other than the fact that it's going to be a new cap that's in the unit. So I'm going to change it because I've already got it out. And I'm going to do that for the remaining caps on the main board and on the preamp board as well. Just because I'm doing an overhaul on this amplifier. Not because it needs it. Next one out. This is the 100 at 25 volts. Again, we'll test it. It's going to be fine. .56. 100 at 25 volts should be, well, this one here's it crept up a bit. A new one would be 0.32. This one's gone to 0.56. But we're going to change this one out as well, like I'm going to do for the remainders. There will be ones on here that are bad for sure. At least on mine they were, and it was affecting the Phono preamp. So the next one is this one in the middle of the board here. I think that's it there. It's this one. Another, this is a 220 at 10. .6 would be considered normal for a new one, and this one's 0.38, so this one's fine, but again, we're going to swap it out. There are some that I'm not going to change. I'm not going to bother with the ones in the protection circuit, for example, because they don't contribute to the sound. I'm only changing the capacitors that are directly in the audio circuit itself. Rubicon. That's what's going in. Something else I need to do on this one is I need to inspect the connections on the various transistors just to make sure that there's no connections that are ready to fail due to heat in some of the big resistors. I've done the caps on this board now, all the electrolytic caps, with the exception of the two bipolar caps, the red ones, because I don't have those. They are very difficult to try to source those ones. They are what they call audio grade caps, and you need to get the right ones for that. Like changing the voltage or changing the capacity on them will affect the sound. And on mine, they tested fine when I tested them. I haven't pulled them on this one to test them because I don't want to add extra stress to the leads, just removing them and putting them back in. But they should be fine because the unit itself is sounding good as it is. So I've changed the other 5 caps per side. I don't need to worry too much about these ones. These are some of the high voltage caps that isolate the high voltage from the plate of the tubes. They are not electrolytic caps. They are a solid type cap. And so I don't generally need to worry about those too much. I'm going to check the solder connections on the outputs and the drivers here, and then we're going to go to the preamp board because there will be caps on the preamp board for sure that have failed. And that's the only one I actually expect to find caps that are actually out of spec. All the ones that I've tested so far have been better than spec. There was a couple that were a little bit closer. Actually, there was 2 that were slightly over the spec for new caps, but the rest of them, like ESR wise, the rest of them were well under the rating for a new cap, but they've been changed anyway. So I've changed out 10 of them right now. So we're going to just check the solder connections on here, and then we'll do the other board, and then we'll clean the record out selector switch because they're going to need to be cleaned as well. And then we'll give this thing a once over. Here's something that's kind of unnerving. When I run my fingers across the metal, I can feel like a buzz, like there's voltage, like there's leakage. You know, you get that AC buzz. But the thing is, this is not plugged in. What it is it's connected up to the audio input, which is connected to my MP3 player, which is connected to my Akai amplifier. If I unplug the input wires, that sensation of the chassis is energized goes away. I wonder if there's leakage coming in from my other amplifier. Let's just put the voltage meter in AC volts and see whether there's any leakage coming in from the Akai. Now the Akai amplifier is plugged in directly. It's not going through an isolation transformer. When this one's hooked up, it's under test, it's going through an isolation transformer. So if I put my meter, plug my meter into the ground port, and I see that I've got 0.5 volts AC that's leaking in from something else, probably the Akai. It does not have a polarized plug. Let's just turn the plug around and see whether that leakage went away. 0.1. Do I still feel it? I don't feel it now. I do not feel the buzz of AC current leaking through. If I turn this plug around again, polarized plugs, right? I now feel it again. And when I measure the ground, 0.5 volts. Turn it around, 0.1. So I was feeling half a volt AC when I run my fingers across the chassis. I'm not now. That's just leakage that was coming in through this unit. Either this one or the tuner. No, the tuner's not even turned on. It would probably have been this unit here, because it's going out through the audio leads and coming back to this, because this is connected to the MP3 player, which is also connected to this. This is connected to the tape out on this one. So I'm getting some feedback, so I just turned that plug around. That's why polarized plugs are kind of important, and why we have them on all the devices these days. But when old relics like this were made, does this have a polarized plug? Yeah, this one does, but the Akai does not. I'm going to mark my plug live and neutral so that if it gets unplugged, I know what way to plug it back in. Someone I know is going to take exception to this, and they're going to say that the amplifier is dangerous and it needs to be repaired and there shouldn't be any voltage leaking through. But in reality, if you go to look at the input, or you go to look at the way that the power transformer is wired on all these devices, all these consumer devices, one side is usually coupled to the chassis through like a disc capacitor. So normally it's the neutral side, right? But without having a polarized plug, you could have a 50-50 chance that that capacitor would be coupling line to the chassis instead of neutral. So they're not fully isolated. It would be nice if the power cord came in and it just went to the transformer, everything would be totally isolated. But they always bypass it with a cap on one side, and That's why some commercial amplifiers, they would actually have a switch on the back, mostly vacuum tube stuff. And I'm talking like musical instrument amplifiers, like Sun or Fender or any of those, or Mesa. They'll have a switch, so it'll be two-way power switch. Flick it one way or the other, and basically what it does is it's just a crossover switch. So it's a 3-position switch, on, off, on. And what it does is it reverses the hot and neutral, so that if you were getting a buzz through your amplifier from your guitar, for example, you're getting a hum or a buzz, you flip that switch and that would reverse the line cord. But that was pretty common on the old stuff. So I'm just going to go over, and I don't see any connections that are really obviously bad. Not like a Sony, for example. I hear a cat hollering for attention. I have a cat that, if you don't give him attention, he will sit there and howl like a small child. If you don't give him attention, he's going to get upset and start to make noise because at least he's not sitting out in front of the door. Quite often he'll sit in front of the door and he'll howl at me because he wants me to go and pet him. Or he wants to play. Cat likes to play fetch. So if he wants to play, he will sit there and howl at the door or wherever. Usually when I'm trying to sleep, outside the bedroom door, howling away because he wants some attention. Or he's hungry. One of the two. I'm just going to go over some of these connections. They all don't look particularly bad. In fact, they look pretty darn good, considering some of the crap that I've seen on some of those Sony amps in the past with just pathetic soldering or heat stressed solder, because the transistors in some of those amps tend to get really, really hot, and the heating cooling cracks the solder, especially the lead-free variety. But this one, it seems to be pretty good. Looking at this one, gonna get my bigger magnifying glasses on here so I can inspect it a little closer, and we'll go over. I'm just going to say, I'm not going to resolder them all. I'm just going to kind of look at them. If they look like they might benefit from a reflow, like these driver transistors look like they could benefit from a bit of a reflow, we'll do it while I've got it apart. I should have really checked the voltage on the caps on this thing. I totally forgot too. This being a tube unit, I bet you the high voltage caps probably still have a bit of a charge on them. I didn't discharge them. Let's just see, because this being a vacuum tube unit, you know, if the tube's running conduction, there might be some voltage stored on here. But then again, probably not. I'm sure they have bleeder resistors on here to take it down. Yeah, 0.1. I didn't check them, but yeah, the caps are all fully discharged. That's probably something that you should do if you're going to work on one of these units. Is make sure the B plus is down to 0. They should have bleeder resistors on them. I haven't looked at the schematic, but this being from relatively modern vintage, like this wasn't an old amplifier from the 60s or 50s when they didn't think about anything to do with safety. Most of this modern stuff, there will be a high ohm resistor that's across the B plus and the B minus lines to drain out any residual voltage when the power's turned off. Most of the ones I've seen anyway have that, so check the other channel out here and see how these ones look. I mean, most of these connections, I don't see any that really look particularly bad. Maybe this one here. You know, this one here looks like there might be a bit of cracked connection right on that one, right where my fingernail is. But really, these transistors look to be in really, the connections here look to be in really good shape. I can't fault them. I mean, these were a really good amp. This was expensive though. Like I paid $2,000, over $2,000 for mine. And that's a 65 watt or 60, I think it's 65 or is it 60? 65 maybe per channel. It's not a lot of power. I wanted to go to the 80 watt per channel amplifier, but it was like $500 more. These were not cheap. These were a very expensive amplifier when they were new. And I bought mine new. And my friends all told me I was stupid. They told me how stupid I was for spending that kind of money on a 60 watt amplifier and how I could have got myself a little Sansui or something that was more powerful and cheaper. And I probably could have. But I wanted those vacuum tubes. I wanted that tube sound, and I was going to pay to get it. I've never regretted my LV103 since I bought it in I think it was 1984 maybe? I think it was 84. It was either 83 or 84. But I've never regretted buying that amplifier. It's given me no trouble other than the switches that needed to be cleaned on it and a couple caps in the Phono preamp. And I did the other ones just as I've done on this one, just for good measure. We're on the preamp board now. I'm going to remove the shield. On this board there's resistors, a couple of resistors that have been known to break free. This is one here. You can see me moving it from the other side. You can see it moving when I wiggle it on the other side. That one there is cracked. These are big power resistors. We're going to resolder those. There's also a couple of regulator transistors on here that need to be redone. These are parts that get quite hot, so they have a tendency to break the solder. And of course the caps on the preamp board, which is the ones that went bad on mine, were all on this preamp board. And there's an IC here. They call it Q2105. Yeah, these are all cracked. You can see them. See them on camera? They should show up. I can see them with the naked eye, so you guys should be able to see these no problem. These are the regulator transistors that I'm talking about. Now, many of you might wonder why here I am working in the shop. It's only 3 o'clock in the afternoon on a Monday, and I'm normally at work on Monday. Well, that's because today is a holiday for me. It's for me, it's Truth and Reconciliation Day, which was actually September 30th, but we all don't get the same day off at work. We get our day booked at a future date, and for this year, it's today. And for those of you that are not in Canada that don't know what TNR Day is, well, you can look that up. But basically it's a national holiday that we get to recognize the Indigenous people of Canada and some of the horrors that they experienced 150 or so years ago when the settlers started to colonize Canada. So it's been called for a long time by the First Nations community, and finally we have a federal holiday that federal employees get off. Not everybody gets the day off, but anybody who works in a federally regulated industry, such as I do, we get a paid holiday. Paid holidays are always great. I like paid holidays. I can hear people screaming about that right now. Typically those that are jealous because they don't get a paid holiday. But the same is true for our provincial holidays because we don't necessarily recognize them. Like everybody gets a so-called family day off, and I gotta work it. So there. And I think that these big ones down here, these big ones are going to be bad for sure on here. Yeah, you see what I mean? That was bad. I'm pretty sure that one's going to be bad. We'll just measure that one and check it, but yeah, it looks to be like it may have been leaking some crapola. 100 volt at 47 microfarads. I bet you this one here is going to be off the scale open. I could be wrong, but I bet you this one's bad. And what does it say? 24? Yeah, I think that's bad. What do you think? 100 microfarad at 100, 47 microfarad at 100 volt. Should be like 0.7, and we're at what, 24? These two are bad. So these two got to go. Let me find a couple of caps. We'll change those ones out and then proceed. So I don't have 100 volt 47 microfarad caps. That means a special trip in to pick them up, which I don't feel like doing. So I'm going to make my own. You can make your own using two 100 microfarad caps rated at least 50 volts, and you put them in series. Now, unlike when you're making a non-polarized capacitor where you put the two negatives together, this case you put the positive from one to the negative of the other, and that will double the voltage and half the value. So if I put two 100 microfarad capacitors together in series, I will end up with a 50 microfarad capacitor rated at 100 volts. So we'll twist the positive of one to the negative of the other. We'll do the same for the second because there's going to be two caps that do need to be replaced on this one. We'll make two 50 microfarad caps rated at 100 volts. This is a pretty common practice. We used to do this quite a bit at the shop to make our high voltage caps if we didn't have them. And again, this is not a critical part. It's in the power supply, so it's not like it's handling audio signals. It's just filtering out the power supply for the regulators for the preamp. The other one is back here. And so one's bad, the other one will also most certainly be bad or getting there. So it should be replaced at the same time. We'll pull this other one out, and of course you can see that this one's been leaking all over the board too, so this one's also bad. And of course, these being electrolytic, you got to pay attention to polarity, otherwise you may have yourself a magic smoke scenario. The red caps on this board, these are bipolar, even though this one's marked with a positive and negative. It is in fact a bipolar cap that's in there. say on here BP for bipolar, and there's no, of course, there's no polarity marking on the capacitor itself because it can go in either way. These ones generally are not going to be bad on this one. They weren't bad on mine. I took mine out and checked them. They were fine, so I left them alone. It was just the main filters that went bad, which also went bad on this one, and they've been now changed. So at this point, I can hook up a turntable to this unit and test it. Amp is working. Let's go get a turntable. I'll set the top cover on it for now without fastening it down, just so I have something to put the turntable on, so we can make sure that the phono input is also functional. Got my modded PST22 connected. This is of course the one that can do 78 RPM now. Let's just try this record. That does it. It's working. So there's one last thing I need to do. I do need to clean the switches. I'm sure the switches for the record out are as in foul shape as the others were. So let me get the top back off this unit. We're going to clean those switches, and of course I've got to put the shield back on the preamp, but I just wanted to test it and make sure everything was good before final assembly. So I've got the CD output, or I've got the CD input switched to the output here. If I switch it in, so I check all the inputs. These switches might not be as bad a shape as the other ones. Actually, they're not noisy like the other ones were. So let's just try the other inputs. Try the tuner input. That seems to be okay. That switch seems to be okay. We'll try the AV auxiliary input. AV auxiliary is that's over here, if I'm not mistaken. Front input is on the front here. And there's a tape 2 to 1. Make sure this is plugged into 1. And we'll go to tape 2. And go 2 to 1. I think and then off. So I think the inputs are okay on this one. If I switch to the AV input, where is it here? What input am I on here? Oh, I'm on tape, of course. Let's try tape 1. Tape 1. There we go. Tape 2, and then tape 1 is this one here. Go up to the tuner input and check the tuner input. You know the Phono works because I tried it. I think this one is ready to go back together and go back to its owner. Power off. Remove the power cord. I gotta put this piece back down in through here. Alright, now time to put the bottom on it and say this unit is pretty much ready to go back to its owner. It's had all the necessary capacitors replaced. In this case, there was really only 2 that needed to be changed, and that was the 2 that were on the preamp board that had gone bad. The other 10 were changed just for good measure. Okay, this one's back together. We can power it up and do one final test. You'll see how slow these units are when they have not been left in preheat mode. If I turn it on cold, because it's been unplugged, it is going to take this thing quite a while before it is ready to produce music, because the tubes need to heat up. It's on tuner input now, and as you'll see, they really do take a while when they're cold to come on. Like in that long. That's why there's the preheat button. Normally you leave the preheat button on the front. There's a switch. You normally leave that turned on. What that does is that keeps the filaments turned on to keep the tubes heated up to almost operating temperature. It operates them at a reduced voltage. I think these are 6-volt filaments on these tubes, so they run at around between 3 and 4 volts. They drop the voltage down, obviously, to extend the life of the heaters, but to keep them warm, so that when you turn on the power, instead of having to wait like 40 seconds to get sound, you get sound right away. Well, relatively speaking, you get sound within about 10 seconds or so. About that long. That's about how long mine takes as well, but let's just say when the preheating was turned off, it can take upwards of a minute because the protection will not kick in. The protection on these amps is something to be desired for every amplifier. And it's because they use vacuum tubes. So as the tubes heat up, as the plate voltages, as the cathode's heating up, the plate voltages will be all over the place. There'll be huge swings in the DC output, which would make it to the MOSFETs. So you would have huge swings in your speaker initially when they're warming up. And once they get up to operating temperature and everything's balanced, then and only then will the relay kick in to turn on the speakers. So because of the warm-up time required, and of course the two tubes, see these are dual triode. So it's like having 4 separate triodes in it. Each tube has 2 separate triodes. So as they heat up, the tubes come into conduction slightly differently, just like having 4 independent tubes. So as they warm up and the gain is changing on the tube as it's warming up, you will have a DC voltage that will go through the outputs, which could damage your speakers if it was to make it to the speakers. So the speaker protection circuitry in these amplifiers is very sensitive. It will kill the speakers if it detects any DC voltage whatsoever. It will not turn the speakers on until the voltages have all stabilized. And if you try to exceed the maximum output power, they will cut the speakers off, which is one of the annoying things that I found with this amp. Is you got it pounding, everything's sounding good, and all of a sudden some transition in the music happens which would require more power, and they just cut out. And then they come back on like 3 seconds later. That's the most annoying thing. You really can't clip an amplifier like this because it'll shut it off before it clips, which is a good thing. It protects your speakers. It protects the outputs. And I've yet to see one of these with blown outputs. That says something about the design. I like these amps. I really like the design of this amplifier. And as I say, it was expensive when I bought it, but I think it was worth every penny that I paid for it. Anyway, this one's done. It's going to produce nice sounds for the owner for years to come. Thanks for watching.